So today we're going to look at the second to last rule for exponents. We looked at how do you multiply exponents, how do you divide exponents. Today we're going to look at the situation is, what if your exponent has an exponent? How do we combine this to make a single power, right? So this is called power of a power. That's what this is called. So the goal is take this whole thing here to have one base, one exponent. And just like with multiplying and dividing, does the base ever change? No, right? So the base is going to stay the same. So the key is to identify the base. So to identify the base, we look at the innermost exponent. We look to the left, and what do we have sitting there? That's our base. Okay? So the base stays the same. So that's the first thing I'm going to want you guys to write down. The base. The next part is trying to figure out what could the exponent be. So I have an exponent 4 here and an exponent 5 here. I want to combine these together to make a single exponent. Who wants to take a guess what the single exponent might be? Jaden.
You add.
Jaden thinks that we add, and so if we add it together, we have 3 with a 9. How many people agree with 3 exponent 9? We got 3 other people. Okay, who thinks it might be something else?
Multiply.
Sorry?
Multiply.
Multiply. So that'd be 20. Who agrees with exponent 20? Another 5 people, a little bit more. Okay, who thinks it might be something else? Christian, do you still have your hand up?
No.
No. So those are our 2 guesses so far. All right? Remember with this chapter, if you don't remember the rule, we always go to repeated multiplication. And that can help us figure out what the answer is. All right? So this is a little bit of a pain. All right? So we start with the outside one. Hey, it says repeat this bracket 5 times. Right? So I'm going to repeat this bracket 5 times. 1, 2, 3, 4, 5. Now, I could take this inner one and repeat this 3's, but I'm kind of lazy. I don't want to do that right now. Right? But how many 3's do we have all together?
5.
No. How many 3's are in this first bracket? 4. Right? Because this is technically 3 times 3 times 3 times 3, right? The first bracket, right? So we have 4 3's here, 4 3's here, 4 here, 4 here, 4 here. How many 3's do we have all together? 20. Okay. So without having to write out this repeated multiplication, what's our shortcut? How do we go from here straight to there? Yes, Christian?
Multiplication.
Multiplication. So we multiply. Okay? Multiply the exponents. So you have to remember, hey, when we multiply terms, we add the exponents. When we divide terms, we subtract. When you have an exponent raised to exponent, we multiply. So more things getting added on. Okay, let's practice that. So look to the left of the innermost exponent. What is our base? Right? So what's our base in this case? Christian?
In brackets, -3.
Yes, in brackets, -3. Okay. What should our exponent be? 12, thank you. 4 times 3 is 12. That's it. Now, you're going to get the assignment booklet, and you're like, it seems so easy when Mr. Dollywall did it in front of us. How come I don't understand what to do? The key thing is to be able to figure out the base is, what is the exponent? So I'm just off to the side. I'm going to take sample questions from the very similar questions from the notes. All right, and I'll sort of talk about how do you figure out, oh, no, I don't want to do the exact same one. Let's go 2, 4, 6 like this. Okay? So your final answer, the way it's going to look like, it's going to have the same base, and your exponent that you're going to have is going to take the same spot as the innermost exponent, right? So the innermost exponent is right here, right? And this is my base, right? Just to the left of it. So I'm going to write my base down, and to the right above it, where the innermost exponent is where the new exponent is going to go. Okay, so what's the new exponent in this case?
What?
24. 4 times 6 is 24. Okay, let's do another one. Let's go negative, like this. 5 squared 3. Okay. Find the innermost exponent. Look to the left. That is your base. So what's our base this time?
5.
5. Thank you. Okay. Now, our exponent that we're going to put is in the same spot as the innermost exponent. So where is our exponent going to go?
Right over.
Right where the yellow is. And what number do we have? 6. Now, what about this negative sign, right? That is still there. Okay? So you're combining the two, right? That's where things are going to get a little confusing. Students get, yeah, I get it. I multiply it. But where do you write that number? That's where students start to get confused, right? And I'll help you doing the assignment. You guys are going to have tons of time. Okay. Next up. Okay. What if I give you a question with 2 numbers instead of the brackets, instead of just 1? You know what? It's still the same thing. Okay? And I will explain it, right? So we want our answer to have the same base, just with new exponents. So we look to the left. 5 and 6 are our base. 5 times 6, like this. Now technically we don't need brackets around this because there's nothing else out there. Right? But if you put brackets there, it's not a big deal. All right. Now we need to figure out what are the exponents. Oops. Here and here. Okay. Jaden, you have a guess?
1 and 3.
1 and 3. Not a bad guess. Kevin? Is it Kevin? Or did I get your name wrong? Sorry, it's. I'll find you. I don't know. That's my Max.
3 and 3.
3 and 3. 1 and 3. 3 and 3. Blake?
1 and 1 and then 3.
1 and 1 and 3. Well, lots of different things going on. That tells me not everybody understands what's going on. So, how does this work? The 3 says repeat the base 3 times. That's what the 3 is saying. We're going to repeat 5 times 6 3 times. Okay? So, all together, how many 5s do we have? Sorry? 3. So, 3 goes here. How many 6s do we have? 3. 3 goes there. Okay? That is actually the harder case. I'm going to give you a new question. That will be actually a little bit easier. So what if I gave you 5 squared times 6, 4, and put a 3 here. I want to combine these together so each number only has one exponent. Right? What would it be? Damien?
5, 6,
Yeah.
and 6, 12.
You've got it. 5, 6, 6, 12. Just like before, we're going to repeat this bracket 3 times. Okay? And how many 5s do we have? Well, we have 2 5s here, 2 5s here, 2 5s here. Altogether, we have 6 5s. With the 6s, we have 4, 4, and 4. We have 12. Now, this seems different than what we did before, but it's still the same. We take the number from the outside exponent, multiply the inside exponent. Right? 3 times 2 is 6. 3 times 4 is 12. And over here, we did the same thing. Except for, when we don't see an exponent, what imaginary number is here?
1.
1. And a little 1 here, and a little 1 here. So 3 times 1 is 3. 3 times 1 is 3. Still the same rule as above. Okay? So this rule that we talked about here works for an exponent raised to an exponent. Works for the situation where you have numbers being multiplied inside brackets. As long as everything's being multiplied in the brackets, it still works. And it also works if we are dividing. Because dividing is just a special case of multiplying. So it's the exact same rule. Right? So we give these little imaginary little ones. Right? We write our base out again. And we take the number from the outside and we multiply to the inside exponents. So what exponent does the 5 get?
4.
4. What exponent does the 3 get?
4.
4. Excellent. Now if I made it a little bit more difficult, I went 5 squared, 3 to the 5th, and a 4 here. So we still have a 5 and a 3 like this. What exponent does the 5 get this time?
8.
8. What exponent does the 3 get?
20.
20. 5 times 4? 20. Okay? Just simple as that. And I think you guys are getting it. Now, let's do the next stage here. Write it as 2 powers and evaluate. So I want to take the exponent from the outside and give it to the things inside. That's what that's saying. So my stuff inside is here. What's the exponent for the 5? Exponent for the 4? Damien?
They both get a 2.
They both get a 2 because these have an imaginary little 1. 1 times 2 is 2. 1 times 1 and 2 is 2. Okay, first part done. Now evaluate. What does the word evaluate mean?
Add.
Not add.
Calculate.
Calculate. Turn this into a number. So we turn the first number into a number. What's 5 squared? 25. What's the second one as a number? 16. We multiply these together.
400.
400. Sorry. Did I go too fast for somebody?
James just flabbergasted.
Okay. Now, this. Yes, Riley. You can wait until we're done our notes. This is not the order of bed mass. So up to last year, you said you were taught do things in the brackets first. Now, if we did the stuff inside the brackets first, I'm going to do this off to the side. We go 5 times 4 in the brackets. That would be 20. And we have the 2 sitting on the outside. Okay? Then we go 20 squared. 20 to the exponent 2, what would that equal?
400.
The same number. So we haven't broken any rules of mathematics. We've done a parallel approach, which comes in handy depending on what the end objective is. Yes?
Now why can we also do it bracket first?
It depends on what the question's asking for. If the question says, hey, just evaluate,
Okay.
then yeah, go ahead, do this. But if the question asks for powers, then you're going to have to do this, right? And honestly, there's no reason to go this way if you want to evaluate, right? But this technique gets used later on in math, right? Of distributing the powers like that. So I think, oh, one more. There you go. Well, let's do this one. Okay, the bases stay the same. What's the exponent for the 2? What's the exponent for the 3? Blake?
3 and 3.
3 and 3.
It's a 5 on the bottom.
Oh, sorry, that's a 5. Thank you.
Wait, what?
My typo. All right. So now, the next part, evaluate. Now, if you go straight into your calculator and start calculating this, it'll give you a decimal number. At this point on in your math career, if we have a choice, we leave the answer as a fraction versus a decimal. Because fractions are more accurate than decimals, because decimals we have to round. So if you're asked to evaluate a number like this, you take the power on the top and turn that into a number, and that just becomes your numerator. So 2 to the exponent 3, can somebody do that in their head? 8. Right? And that's how you evaluate that. Then you take the bottom number, you evaluate that. What's 5 to the exponent 3?
125.
125. And that would be your answer for evaluating. Okay? And that is it.